The next section that we're covering is section 5.2, and it's called Negative Exponents and Scientific Notation. In the previous section, we reviewed what exponents are, and we looked at a bunch of rules of exponents. We're going to give you one rule today, and it all deals with negative exponents. All right, whenever we have negative exponents, we're going to use what is called the reciprocal rule. Okay, and the reciprocal rule, let's say that we have some base, let's call it x, raised to a negative exponent, and I'm going to say negative n. Okay, anytime we have a negative exponent, we just have to take the reciprocal in order to make that exponent non-negative. And so x to the negative n is 1 over x to the nth power. Okay, and so since it's 1 over x to the n, that's why we call it the reciprocal rule. I have a couple of examples down here making use of the reciprocal rule. In these examples, we want to rewrite using positive exponents and simplify if it can be simplified. All right, in this first example, part A, it says 2/5 or 2 to the negative 5 power. We want to find out what that equals. Well, in this case, we have a negative exponent, that negative 5. In order to ensure that that exponent becomes positive, I need to use that reciprocal rule. So this is going to equal 1 over 2 to the 5th. Okay. When we do 1 over 2 to the 5th, we can now find out that 1 over 2 to the 5th is the same thing or is equivalent to 1 over 32. Okay. And that is most simplified. So 2 to the negative 5th is 1 over 32. Let's go to part B. 9 times x to the negative 6th power. Notice that the negative 6 is only the exponent on the x and not the 9. So when we use the reciprocal rule, we're going to have our 9 still there, and that's going to be over x to the 6th. Okay. Now I have my positive exponent. I can't simplify anything further, so I'm done in that example as well. Let's look at part C. I have a to the 5th times b to the negative 4th, and I want to find out what this will be with only positive exponents simplified completely. Well, once again, I only have one variable or one thing with a negative exponent, and that's b to the negative 4th. Okay, so my a to the 5th is going to stay the same. And in order to get that reciprocal of b to the 4th, I need to put it in the denominator. So that's going to be b to the 4th. So we have a to the 5th over b to the 4th. Part D, we have 4 to the negative 3rd power. Once again, we have that negative exponent. We need to do the reciprocal, i.e. put it in the denominator. So this is going to be 1 over 4 to the 3rd power. And we can simplify that because 4 is a number. That's 4 times 4 is 4 to the 3rd. So this is going to be 1 over 64. Okay. In each of these examples, we started out with just basic things raised, and at least one thing raised to a negative exponent. Notice that they didn't start out as being a fraction. Okay, they started out being almost like whole numbers or almost like regular things. Now we're going to go to examples where we might have negative exponents in fractions. Okay, so let's find out what we're going to do when we have negative exponents in fractions. Our goal is going to be similar to what we did before. Get rid of those negative exponents before and then simplify. Okay, to do that, so to make a negative exponent positive, move it to the other side of the fraction bar. And that's going to be the exact same thing as taking the reciprocal of it. Let's look at a couple of examples. This first example, we have x to the 12th over y to the negative 7th. Okay? And if we look at this example, we only have one variable with a negative exponent, and that's y to the negative 7. Okay? And so what we want to do is get rid of that negative exponent, because the direction says to rewrite without using negative exponents and simplify. That means I need to get that negative 7 across that fraction symbol. I'm going to leave that x to the 12th the same. Y to the 7th is going to come up top. And there's nothing left on the denominator. That doesn't mean that zero's down there. It means a 1 is down there. Okay, so it's x to the 12th times y to the 7th over 1. But anytime we put something over 1, it's the same exact thing. So we stop there. We're finished. Let's look at part B. We have 5 to the negative 2nd power times x to the negative 8th power all over y to the negative 5th power times z to the 4th. In this example, we have multiple things with a negative exponent. 5 to the negative 2, x to the negative 8, and y to the negative 5th. When I see problems like this, I go ahead and write my division symbol. And what I'm going to do next is just flip everything to the opposite side of the division symbol, or the fraction bar. 5 squared should go in the denominator to get rid of that negative 2 exponent. X to the negative 8 is going to become x to the 8th in our denominator. Y to the 5th is negative in that denominator. I'm going to make it y to the positive 5th in my numerator. And since z to the 4th, that 4 is already positive, I'm not going to do anything with that z. I'm just going to keep it the same. So we've moved the things across the fraction bar, and now all we need to do is simplify. In this example, we can simplify, and the thing that we can simplify is the 5 squared, right? 5 squared is 25. So if we want to simplify that, the final answer is going to be y to the 5th over 25 x to the 8th times z to the 4th. And that is how we get rid of those negative exponents. We make them positive by moving them across the fraction bar. There's one more example. It's part C right here. X to the negative 2nd, y to the 4th over z to the negative 1st, w to the negative 9th. And we're going to start in class on this example next time.